Hi everyone, let's check on another question on mathematical induction, that is 1 cube by 1 plus 1 cube plus 2 cube divided by 1 plus 3 plus 1 cube plus 2 cube plus 3 cube divided by 1 plus 3 plus 5 up till n terms is equals to n divided by 24 into 2n square plus 9n plus 13. Okay, so we got to prove this statement is true by mathematical induction or not. Okay, then consider the nth term of the numerator, because here nth term is not given, you got to construct the nth term. Okay, so there are two parts for it. One is numerator and another is denominator. Denominator part you can get by Tn formula, and numerator part you can get it, you know that it is sum of the cubes of n terms, that is which is equals to n square into n plus 1 whole square divided by 4. Then and the term of the denominator, how can you get it? By sum of the terms in AP, right? So 1 plus 3 plus 5 plus so on till n terms, which is equals to n by 2 into 2a plus n minus 1 into d. Here a is equals to, what is the value of a? The first term, right? That is 1. Then after that, common difference d, you need to get the value of d. How will you get it? Second term minus first term, that is 3 minus 1, which is equals to 2. D is equals to 2. Now substitute the value of a and d in this formula, that is sum of n terms. You will be getting it as is equals to n divided by 2 into 2 into 1 plus n minus 1 into 2, which is equals to n divided by 2 into 2 plus 2n minus 2. So plus 2 and minus 2 will get cancelled and will remain with 2 into n, which is equals to n by 2 into 2n, which is equals to n square. Now check on to the tn term. Okay, so you got denominator term as n square, numerator term you know that n squared into n plus 1 whole square divided by 4 whole divided by n square. N square will be cancelled, you will be remain with n plus 1 whole square by 4. Now let's suppose the statement. Let the statement be 1 cube divided by 1 plus 1 cube plus 2 cube divided by 1 plus 3 plus 1 cube plus 2 cube plus 3 cube divided by 1 plus 3 plus 5 plus so on, which is till n plus 1 whole square divided by 4, which is equals to n by 24 into 2n square plus 9n plus 13. Step 1, prove that s of n is statement is true for n is equals to 1. We have to prove that this statement is true for n is equals to 1. Simply take the first term or substitute in this nth term, n is equals to 1. If you substitute, you will be getting it as n 1 plus 1 whole square divided by 4, that is 4 divided by 4, which is equals to 1. Then coming to RHS part is equals to 1 divided by this part. You have to substitute, instead of n you have to substitute 1. You will be getting it as 1 divided by 24 into 2 into 1 square plus 9 into 1 plus 13. Okay, so now 2 plus 9 is 11, 11 plus 13 is 24, 24 divided by 24 is 1, therefore LHS is equals to RHS. Now you can say that S of 1 is true. Now let's suppose that the statement is true for n is equals to k. Okay, so the statement is 1 cube divided by 1 plus 1 squared 1 cube plus 2 cube divided by 1 plus 3 plus 1 cube plus 2 cube plus 3 cube divided by 1 plus 3 plus 5 plus so on till k plus 1 whole square divided by 4, which is equals to k by 24 into 2k square plus 9k plus 13. Now in step 3, we got to prove that the statement is true for n is equals to k plus 1. So let's consider k plus 1 term. K plus 1 term we know, k plus 1 plus 1 whole square divided by 4, which is equals to k plus 2 whole square by 4. Okay, now add this term on the both sides of the equation 1 that we got in terms of k, right? We have assumed that that equation is true for k. So adding k plus 1 term on both sides of equation 1. 1 cube divided by 1 plus 1 cube plus 2 cube divided by 1 plus 3 plus so on till k plus 1 whole square divided by 4 plus k plus 2 whole square divided by 4, which is equals to k divided by 24 into 2k square plus 9k plus 13 plus k plus 2 whole square divided by 4. Okay, now you got to simplify it by taking LCM. When you take LCM, you can clearly observe that 24 and 4 are 24 is the multiple of 4. So in 4 table 24 goes how many times? 6 times. So clearly multiply 6 with the numerator. Okay, so 6 into k plus 2 whole square plus 2k cube plus 9k square plus 13k divided by 24, which is equals to 2k cube plus 9k square plus 13k plus 6 into k square plus 4k plus 4 divided by 24. Now taking common all the values, you will be getting it as 2k cube plus 9k square plus 13k plus 6k square plus 24k plus 24 divided by 24. Okay, so on simplifying it, you will be getting it as equal to 2k cube plus 15k square plus 37k plus 24 divided by 24. So now we have to get something in terms of k plus 1, right? Now if you observe, if you observe here in the first equation, that is very first equation, this equation, here we should get k plus 1. Okay, so clearly at this part we should get k plus 1, and at this part we should get k plus 1, at this part we should get k plus 1. Okay, so for getting that, here in the numerator part, firstly common term we should get k plus 1. Okay, so let's check how do we do that. Okay, now as we simplified it, we just have to get from this equation only, from this equation itself, on the RHS part you have to get in terms of k plus 1. Okay, so for that you have to separate 2k cube plus 2k square. Okay, so if you separate and check it out, you will be getting as 2k square into k plus 1. So you got for one term. So similarly for the second term also you have to do. You are splitting 15k square as 2k square plus 13k square. So here you got 13k, and here from this 37k you take 13k, and you will be remain with 24k plus 24k. So now if you take common, you will be getting as 2k square into k plus 1 plus 13k into k plus 1 plus 24 into k plus 1 divided by 24. So all in all, if you can check, you will be getting k plus 1 as common into 2k square plus 13k plus 24 divided by 24. Now here also 2 into k plus 1 whole square or something we should be getting, right? So just take 2k square as separately, and then in order to get this whole square, that is 2k square in terms of some whole square, what we are doing, we are just simplifying it out. We are just getting 4k out of 13k, and here we are getting 2k out of 2 out of 24. Okay, the whole thing is just in order to make it in terms of some 2 into k plus 1 whole square or so. Okay, so 2 into k plus 1 whole square. So now if you check out 2k square plus 4k plus 2. Okay, now these three terms you will be taking it as one side. Now you will be remain with, from 13k you are taking 9k over here, and here you will be remain with 22. So 9k plus 22 divided by 24. So till here, is it clear? Then let's move on for the further step. Then 2 into, if you take common, k square plus 2k plus 1 plus 9 into k plus 9 plus 13. Okay, now 9k in plus here from this term you take 9 common. Okay, so we need to get in terms of 9 into k plus 1 also, right? So that term you are taking it as common. You will be getting it as k plus 1 into 2 into k square plus 2k plus 1 plus 9k plus 9 plus 13 divided by 24. Now you got it as k plus 1 into 2 into k plus 1 whole square plus 9 into k plus 1 plus 13 divided by 24. Here this term you can write it as k plus 1 whole square, right? So the same we did there. So is equals to k plus 1 into 2 into k plus 1 whole square plus 9 into k plus 1 plus 13 divided by 24. Therefore s of k plus 1 is 2. Then by the principle of mathematical induction, you can say that the statement is true. S of n is true for all small n belongs to capital N. If you have any doubt, please do comment in the comment section. And for understanding the simplification part, that is this part, please do watch it again twice, thrice. If you watch, you will be able to understand. Okay, thank you so much for watching. If you have any doubts, please do comment in the comment section. Bye bye.